So the way this works, you have a cone that centers the rotor in the center here, and then you have a plate that mounts to the bottom of this. Now, the problem is, if you look at this mounting surface, it's all rusty, right?
Yeah.
So we're going to sandblast or media blast that off. Do that first. Preparation for machining, you got to have a flat surface here.
Right.
So you got to remove all the rust. So that's an after. This one you'll probably see. See, this is here, right here. Now, but before I cleaned the shaft here, and I cleaned the cone, and I cleaned the cups so that this thing would fit on nicely.
I asked my wife to clean but it didn't work out so well.
This is being recorded, Andrew. Your wife's going to hear this.
Okay, that's okay.
So anyway,
maybe it'll encourage
the cone is spring-loaded, so it centers the rotor. All right. So you want to keep the rotor under tension all the time because you don't want to drop the rotor on the shaft.
Gotcha.
So you hold it like that. This is a anti-vibration coupler, a left-handed nut. So you get it hand tight like this. That's hand tight. See, then you bang on this a little bit around the edge. See how that rotated?
Yeah.
Because what you have to do is you have to center it.
Yep.
Gravity's working against you, so you got to kind of center it. So after you do that, you loosen up the cutters like that. Then you got to see if your rotor is true or not. So you go on this side over here, start taking a scratch cut. Take one scratch cut, move the cutter out a little bit, loosen up the rotor again, just enough so you can rotate these cones and the cups. Because what you want to do, if you got any rust or anything on there, you want to scrape it off so it doesn't affect your machining operation. Tighten it back down again. Take another scratch cut. Now, do you see the inconsistency between the two scratch cuts?
Yeah. Oh, yeah.
So what we're aiming for is one consistent scratch cut.
And it's all about just getting it set up so that you've got it in the right plane, right?
Yeah, you got to make sure this is all set. So.
All right. So you're trying to snug it up as you're banging it a little bit? So it
yeah,
kind of
I'm keeping tension on
got
it right
yep,
there
yep,
as I
yep,
do
yep,
that.
yep.
So
that makes sense.
we go out again, take another scratch cut out here. Now, I do have a consistent scratch cut at this point.
Yeah, you got two
that are the
two
same.
that are correct and one that's off.
Yep. Interestingly, the one that's off looks truer than the other two, doesn't it?
It does, but...
So we'll try this again. Because you can take as many scratch cuts as it takes to be sure you got it right, because the penalty for getting it wrong is real simple. Your brakes will vibrate. Nobody wants that.
No.
So this is what takes time, getting a good setup.
No, that first one was off. You got three now.
Yeah, I got three now that are the same.
I would go with that.
So now what you do, you got to put your anti-vibration damper on the rotor. That's what this device is here with lead weights.
Yep.
So you got to hold it right there, pull it around here, put this hook thing here right like that. You got that on. Then you need to get the hockey pucks positioned. And the hockey pucks are back on the back side here. What you do, move those out to the rotor, put them under tension, tighten those down. So now we've got our vibration damper here, hockey pucks here to dampen those vibrations. Now we're gonna find our 0 point. Okay. So there's 0.
Yeah.
Holding the outer dial, that's what controls the cutter.
Gotcha.
This inner dial is just your guide. So I found 0 there, and I'm gonna find 0 out here next. Now when I find 0, what I'm looking for is a cut that goes all the way around, which I now have.
Gotcha.
So tighten those down. I'm gonna cut off some material. Raw material is a very raw cut. What I'm going to do is get this outer edge cut down here. They go all the way in now. This is where I hold my breath. See all that stuff flying off? That's why you hold your breath at this point, unless you're wearing a respirator, which I strongly recommend. When I get down to the far inner surface here, it's going to take off more as it gets to the edge. Right about here.
Right, because the pads don't run there.
That's right. So basically what I've done is hog off material on the rotor. You can kind of see it here.
Yep.
Now I can take a real fast cut here and do some more of that. See how fast the wheel is turning? It's just going to take off more metal.
This is still at 0, right?
Yeah, this is still at 0. I'm just trying to get to a surface where I can take a fine cut at a slow speed and have it be productive. Right now the cutter is hitting a spot, not hitting a spot, because there's an area here where the rotor is a little bit worn cockeyed.
Interesting. About the same on the other side too. Interesting.
Cool. This cut is
It's kind of nice. It's very slowly kind of drawing it back.
Yep.
Yeah, that's neat.
so this fast cut, just for removing large quantities of metal to make the surface machinable. I don't usually use the fast cut for doing final machining because it's too coarse. You can see where this is where you can watch it compared to the slow cut where you go do something else.
Yeah. Yeah, that's what got this. What you said, 15 minutes?
Yeah, take go. We should getting all the rough spots off by doing this.
No, that makes a lot of sense, right?
So you see there's a couple areas where the rotor's worn in a different pattern.
Yep.
Yeah.
Same on this side
Got
too.
very quiet there for a moment.
Okay, so now disengage the feed, crank it back in. We'll take our first cut now of any serious material. I'm taking, based on what I see here, I'm going to take 3/1000ths off. And same thing on the inside. This one's actually got a little bit more, unevenness compared to the other one. Now this will be at a slow speed, so then we'll just walk away and wait for it to happen. Right?
Yeah. Okay. Very
Now,
cool.
One thing that is very important when you're cutting a rotor, I found out on that first cut, is that the cutters need to be inspected. These are 6-sided cutters. And the way you do that is with this tool right here called the brake lathe inspection tool, also known as a magnifying glass. So what you do is you unscrew the cutter, you hold it up to the light, you take a look at it, and you see how many edges are cut, have been used already. Then you turn it around to a fresh edge, screw it in, you're ready to go. That's how I got that good cut on that one. Because the first cut I took, every edge saw it was kind of rough. But the last cut came out real nice.
So about how much do you think you took off on that? About 3 pounds?
Yeah, probably maybe 4 each side, so maybe 8/1000. Not much.
No.
No, they were in pretty good shape to begin with. So
That's great to know.
this is just going to take a while. You might want to pause that. We've completed our first cut at 3/1000ths. Slow feed. Shut the machine off. See how it looks. Pretty smooth. So now, after you've got the smoothness, we're going to put a non-directional finish on it using our trusty Makita and our brush hone. Reason for a directional finish, a non-directional finish, is so that you minimize brake squeak and vibration. And what this does, this knocks off any high spots from the machining operation. The brush hone has got nylon bristles that have silicon carbide balls in the end of them. It's pretty hard, and it'll give a nice finish to this. See, it gets rid of those high spots. Now it's very, very smooth, ready to bolt on after cleaning. Now the other side, the other side over here didn't do as well because we have a few spots where the rotor didn't get machined. So we're going to take another cut on this side right here. And based on how it feels to me, I think another 2/1000ths max will do it. Now, when you're cutting only one side of the rotor, obviously the cutter on the side that you're not cutting should be backed off because you don't want to cut a side that's already done. I'm going to turn the machine on, run the cutter bar in. Loosen up the lock, dial another 2/1000ths on it, tighten it down, turn the slow feed on, and away we go. We'll be back in about 15 minutes when this side is done. So, we've completed our cut on both sides. We've got a non-directional finish on both sides. Now it's time to take down the machine. The way that happens is we take the vibration dampener right here, also known as the hockey puck, loosen up the lock screw, rotate it to the back, take the inner one, loosen up the lock screw on that, rotate that to the back, take our anti-squeak strap, hang it from the hook, disconnect our device here, arbor. When you disconnect the arbor, you got to hold this so you don't drop the rotor onto the shaft. Dropping the rotor on the shaft is considered bad form. Isn't it, Rick?
Yes, sir. Did you already put a directional finish on that?
Oh, yes. A directional finish is on it. We hang up our tools like a good citizen, and here is the finished product.